This video covers the notes over 11.3, which is the topic of negative and zero exponents. On your on your blue formula chart in your little baggies, or if you're using one at home, there's a rule that says negative exponents, a to the negative n, is the same thing as 1 over a to the n. So what this is telling us is if we have a negative exponent, basically, negative is unhappy. Think about someone who has a very negative personality. They're angry, you don't like talking to them, they're not a lot of fun to be around. So if they're negative, we got to change their view or change their problem. Get rid of their problem, if you will. So we can change that in to be a happy person by moving it to where it wants to go. So basically, we're spoiling our exponents and putting them where they want. So with these examples, we can just plug these into the calculator because we have all numbers. So in your calculator, you're going to click 6 raised to the negative 4. The arrow takes you up, and then we would click enter. And it tells us this ugly decimal. So remember, if we click math, enter, enter, we get the fraction 1 over 1296. The second one I'm going to put in exactly like I see it in my calculator. I have a negative 4 in parentheses, so I'm going to put that negative 4 fully in parentheses. And then it is being raised to the negative 2 power, so I put it in exactly like I see it. Math, enter, enter, and I get the fraction 1 over 16. And for the last one, I'm going to put it in exactly like I see it. So we have the fraction 1 over 2 raised to the negative 3. So I'm putting this in exactly like I see it. And I get the number 8. The reason being, this negative was unhappy, so we bring it up to the top and make it positive, and 2 cubed is 8. There's another cool little rule that anything to the 0 power is 1. So anytime you see a 0, basically it cancels. If that's the only thing you see, it equals 1, or if it cancels, you can just ignore it. So 5 to the 0 is 1. Negative 2 to the 0 is 1. This ugly decimal to the 0 is 1. This fraction to the 0 is 1. So anytime you see anything with a 0, you can cross it out and cancel it out. If it's the only thing left, you have to use a 1 as a placeholder. So when we look at example 1, we have 11m to the negative 5. Remember that we have our base with the exponent up at the top, and the exponent is only on the base that it is directly next to. Unless you see parentheses, it's only on that base. So for problem 1, m is the only thing being raised to the negative 5. 11 has an invisible 1. So to get rid of the negative, I'm only going to move the piece that has the negative. Now again, this m is very negative and unhappy on top, but if I move it to the bottom, then the m becomes happy and becomes positive. Now the 11, remember, has that invisible power of a 1. 11 is already happy, so 11 gets to stay where it is. M is the only thing that's going to move. So 11 over m to the 5. These problems, you need to make sure that you are very careful with your negatives. We'll see some problems involving negatives in a minute, but if you end up with a negative exponent, you need to move it so that it becomes positive. Note, once it is moved, it becomes positive. I only move the negative exponent. So for problem 2, only dealing with the negative exponent. The negative 4 and the y are happy where they are, but the x is not happy. If I bring the x to the bottom, it becomes happy or positive. So I move x cubed to the bottom and make it positive, and now it's happy. The negative 4 and the y were already fine wherever they were, so we keep them wherever they are. In problem 3, we have a negative exponent. This y is not happy being on the bottom, so we need to put y up on the top. There is nothing left on the bottom, and the 1, you can put 1y cubed or just y cubed. The 1 isn't really a huge deal for this problem. So 1 over y to the negative 3 becomes a positive. Now problem 4, we can see there's a negative exponent. However, one thing I want you to do is wait until the end to deal with negatives. If you wait until the end, some of them will fizzle out, they'll go away, and you don't have to worry about them. And so that's what we're going to see if it will happen here. So with this takes us back to our 11-1 rules where we multiply the big numbers. So 4 times negative 2 is negative 8. And we add the little numbers. So m to the 2 plus 1 is 3. N to the negative 2 plus 4 is 2. Now when I put my answer back together, I have negative 8 m cubed n squared. Notice I no longer have negative exponents because they were taken care of. So what I want you to do, if possible, wait until the end to deal with negatives because sometimes they will work themselves out. If they don't work themselves out, then you have to get rid of it or move it or whatever. So 5 is very similar. Multiply the big numbers. 5 times 3 is 15. We have a to the negative 3 plus 2, which is negative 1. And then b to the negative 1 plus 1, which is 0. So remember, anything to the 0 power cancels. So right now I have 15a to the negative 1. My a is unhappy where it is, so it wants to move to the bottom. 15 is fine where it is, so 15 will stay. And then a becomes a positive when we move it to the bottom. Problem 6, we distribute that power. 4 gets cubed, and a to the negative 4 gets cubed. 4 cubed is 64. These are on top of each other or piggybacking. When they piggyback, we multiply, so negative 4 times 3 is negative 12. Now this can't be my final answer because as we learned today, we can't have negative exponents, so we move a to the bottom and make it positive. 64 is fine where it is because it doesn't have a negative exponent, so I leave it where it is. So today, if you end up with negative exponents in your answer, you need to take care of them. In the past, we might have been able to move on, but because we know the rule today, we have to observe the rule today. So we have just a couple of problems on the back. Now, one thing that you can do is move negatives if you see them in your fractions. Like, for instance, a has a negative and a negative, so I could rewrite these and switch them. Okay, so a to the 5 comes up to the top and becomes positive. A cubed goes down to the bottom and becomes positive. However, if that confuses you, you can follow the exact same steps we're going to. Just make sure you really watch those negatives, and you have to think about which negative is bigger so it gets a little confusing. Now with this, we're dividing, so we divide numbers like normal. 24 divided by 6 is negative 4. And we subtract, and remember when we subtract our exponents, we leave it where the bigger exponent is. So a has more on top once we got rid of our negatives. It does still have more on top here, it's just weird for us to think about, so that's why it's easier if you flip them. So a has more on top, b has more on top, c has a 0. Remember that anything to the 0 cancels. So a to the 5 minus 3 will give us 2. b to the 4 minus 2 will give us 2 as well. Both of these are left on the top because that's where our bigger one started. So negative 4, a2, b2 is going to be our answer for this problem. Problem 8, first thing I'm going to do is distribute this squared because I have something in the parentheses that I need to take care of. My first term is staying exactly the same. Again, the only time you need to take care of moving negatives is if they're in a fraction like this and you have 2 of them. Otherwise, I would leave them and wait to the end. So here everything gets a squared. So negative 3 gets squared, x to the negative 2 gets squared, y cubed gets squared, and z gets squared. So my first term stays the same. In my back term, negative 3 squared is 9. Make sure you put that entire thing in parentheses because negative 3 squared is different than parentheses negative 3 squared. These are piggybacked, so we multiply. Negative 2 times 2 is negative 4. Piggyback, so we multiply. 3 times 2 is 6. And then z is squared. From here, I follow my rules from Monday. 9 times my invisible 1 is just 9. X to the 2 plus negative 4 is negative 2. Remember, we're adding because they're being multiplied, and we follow that rule. Y to the negative 2 plus 6 is 4. And z to the 0 plus 2 is 2. Now again, you could go ahead and mark out that z to the 0 from the very beginning. Z is still part of my answer, so it doesn't make a huge difference. The only negative exponent I have is x2, so that's going to go on the bottom because it's not happy being on the top. Everything else gets to stay where it is. Y to the 4th, z squared stay on top, 9 stays on the top, x squared is the only one that goes down. 9, we're going to distribute the power. This time both of my parentheses have powers that need distributing. So 2 squared m squared into the 1/2 squared. And then 3 squared m to the negative 3 squared. Again, we're not moving negatives until the very end. So in green, 2 squared is 4, m squared. These are piggybacked, so we multiply. 1/2 times 2 is 1. And then 3 squared is 9. These are piggybacked, so we multiply. Negative 3 times 2 is negative 6. Now with my multiplication, I multiply the big ones, add the smalls. Make sure you watch your negatives. Into the 1 is just into the 1 because nothing is there to change it. 4 times 9 is 36. Into the 2 plus negative 6 is negative 4. Now my negative exponent needs to be taken care of, and it needs to go on the bottom. My 36 is positive, and into the 1 is positive. You do not have to put into the 1. Another quick note, the moving exponents, because they are positive or negative, moving them because they're negative, only applies to exponents. It does not at all apply to positive or negative numbers. You do not move numbers unless the numbers have a negative exponent, which you can figure out in the calculator. 10 asks me to evaluate the expression 2 to the negative 4 r squared s to the negative 2 if r is negative 3 and s is 4. So I'm in black. I'm going to put whatever is staying the same. So 2 to the negative 4, r being squared, and s to the negative 2 are staying the same. Instead of r, I am substituting in the number negative 3. And instead of s, I am substituting in the number 4. And I'm going to put this entire thing into my calculator exactly like I see it because I have just numbers. I am going to use parentheses. Do not get lazy, because if you get lazy and don't use parentheses, you will get the wrong answer. So 2 raised to the negative 4 times negative 3 squared times 4 raised to the negative 2. Math, enter, enter. And I get 9 over 256 as my answer.